Good morning, students. I hope I'm audible and my screen is visible to everyone. Please acknowledge
Yes,
in
sir.
this audible.
Morning,
Yes,
sir.
sir.
Morning, sir.
Morning,
The
sir.
screen is visible, sir.
Okay, great. Okay, so in the last class we have discussed about the memory. Like we have discussed about the one of the primary component of the memory, that is primary memory, where we have discussed the subtypes of the primary memory, like the static RAM and the dynamic RAM. In today's class, what we'll do is we'll be discussing or we'll get an insight of the second type of primary memory, that is the ROM, read-only memory. Okay, and what is the working principle of this ROM, and why do we exactly need this ROM in order to run our systems? So we'll be learning about that, and as well as we'll be understanding what are the different types of ROMs that are available. And if time permits, then in that case we'll be definitely moving ahead to this portion, which is the evolution of this evolution of computers. Okay, so let's see if time permits, then we'll be moving ahead this moving ahead to this, else we'll stop up to the output devices. Okay, so yes, so in the last class we were discussing this portion where we have already discussed about the RAM, and today's class we'll be discussing about the ROM. Okay, ROM is basically the read-only memory, or we can also classify it to be as the non-volatile memory. The purpose or the reason why we have a read-only memory rather than read or write memory is because uh, see, in order to initiate a computer, in order to start a computer, in order to get started with the system, or in order to load the operating system into the RAM, we will require some prerequisite programs. We will require some prerequisite programs, and that prerequisite programs need to be stored somewhere. Please try to understand it very carefully. Okay, we will require some sort of prerequisite programs, and those prerequisite programs will need to be stored somewhere. Okay, so now the challenge is where to store those prerequisite programs. Can we store it in hard disk drives? Can we store it in solid state drives? Can we store it in RAM? Okay, now these are the list of devices that we know as of now. So in RAM we cannot store that because RAM is completely volatile. So the moment we store the program, or the moment we load the code in the RAM, the moment the RAM shutdowns, or the moment the system shutdowns, the entire data will be gone. So RAM is cancelled. So the next type of devices that we have is basically the secondary storage devices, like hard disk drive or solid state drives or CDs, magnetic tapes, floppy disk, whatever we have. Okay, so we have this sort of devices. So can we store it in secondary memory or secondary storage device? The answer is once again no. The reason is why we cannot store that loader or the program whose responsibility is to load that particular operating system into the RAM is because the operating system is itself going to decide in the hard disk drive, and we don't know what kind of operating system is going to come in the hard disk drive or the secondary the solid state drives, okay, or the CD drives, because all those devices are literally erasable. Okay, erasable by the user or can be erased very easily. So if you, in case if you load the program or the software whose responsibility is to load that particular operating system into the RAM, in that case what will happen, the moment you give a format to those you just try to erase all those data from the hard disk drive, in that case you won't be able to load your operating system. In that case you won't be able to load your operating system. Okay, so how the communication exactly works and how the ROM loads the operating system into your RAM, we'll try to understand that, so that we can understand or we can have a better idea of what is the significance of having a ROM for each and every computing device. Students, I believe you are able to see this drawing board. Okay, so in case if it is not visible, please acknowledge. Okay, so for example, this is your ROM chip or the IC whose name is a ROM. Okay, read only memory. This is your RAM. Like we'll be giving some sort of legs, although RAM doesn't have. Okay, then this is your secondary storage device. Okay, let's say this is an HDD. Okay, hard disk drive, and this is the operating system that you have. Let us assume that this is the Windows operating system that you have, like Windows. Okay, now while manufacturing a computer, the vendors or the manufacturers, what they do, they load a program, they load a specific program inside this chip. Okay, they load a program inside this chip, or in a simple language they load a software inside this chip, and the task of this program is to recognize the operating system and load that particular operating system inside into this RAM, because we know the moment we run a program, it basically goes to the RAM, and from RAM it goes to the processor. From RAM it goes to the processor. So directly it cannot go to the processor from the secondary storage device. Okay, so in order to go to the processor, what it needs to do is it needs to travel through the RAM. But who is going to bring that operating system to the RAM, or who is going to tell the operating system, hey Mr. Operating System, come to the RAM, now this is your part, you need to execute yourself. So that task is being assigned to the software that is being loaded inside the ROM, and we call that software to be as the bootloader. We call that software to be as the bootloader. Okay, who is going to load the booting files of the operating system into the RAM. Okay, so it will go to this. Hey, Mr. Hard Disk, do you have the operating system? Hard disk will reply, yes, I do have the operating system. So as soon as the hard disk replies that I have the operating system and these are the bootloader files, or these are the files by which I will be booting my operating system, then ROM will say, okay, you're free to go. Please come to the ROM, come to the RAM, and please execute your codes. So the programs will be loaded in the RAM, and from RAM we'll have the will have the programs loaded in the processor. Okay, so this is the cycle, or this is the flow which actually works, or this is the working principle, or this is the major task of a ROM chip, that is the read only memory. Okay, we know that whenever we run a program, it will basically load in RAM. Okay, but in case of operating system, who is going to load that particular operating system into the RAM, and that task is being assigned to the read only memory. Apart from that, there is also one more task of ROM chip, is to hold the firmware or the BIOS, that is the information of the basic input output of a system. Okay, the moment you boot a system, you will see there is a software or there is a program whose capability is to recognize the hardwares that are being attached with your computer or that are being attached with your system, and that software is also loaded in the RAM. Okay, so basically if we say all those softwares whose major task is to recognize the hardware or to recognize the software, that is basically the operating system, is being loaded in read only memory. Okay, so all those tasks whose responsibility is to recognize these hardware that are being connected with the system, as well as the operating system that is being stored in the hard disk drive or the secondary storage device, and load that particular system into the RAM, is being stored inside ROM. Okay, so if the concept of ROM is clear, please type Y in the chat box. Okay, great. Okay, so this was what exactly this is what exactly ROM is, and they're working over the major task of a ROM. Like, why do we need a ROM instead of having a separate kind of memory? Because yes, it is read only. You cannot do some sort of modifications as per user choice. Let's say randomly I want to erase the data of the ROM. That is not literally possible. Okay, randomly it is not possible. Like, I can delete a file randomly from my secondary storage device. गलती से file delete कर सकोगे, but गलती से ROM का data delete नहीं कर सकोगे. Okay, because the vendors, they also know. Okay, in case if you fall into trouble, you will definitely wipe out the entire data of the secondary storage device. But there should be some sort of program whose task should be able to recognize the operating system that is being loaded into the system. So if you lost that particular program, then there will be no one to load this hard disk drive, to load this operating system from this hard disk drive or the secondary storage device to the RAM. Okay, so there are certain cases when let's say when viruses gets entered into the BIOS system. Okay, those are viruses which specifically target the ROM chip, or they specifically target the BIOS. Okay, so what they will do, they will corrupt the files of BIOS, or they will try their best to erase the data of the BIOS. Okay, so in that case you will fall in a big trouble where your entire data will be gone. In that case, there are two possible ways. If you have a desktop, or if you have a computer who have a dedicated motherboard, in that case you have the chances to replace the ROM chip. Okay, so there are chances by which you can replace the ROM chip, and but nowadays, since everything comes integrated, so they will recommend you to replace the entire motherboard. Okay, so they most of the cases, the vendor, what they will do, they will simply say, okay, so you have a problem with the motherboard, just replace the motherboard. They won't say that you have a problem with your ROM chip. They won't say that. They will directly say that just replace the motherboard, and that is going to cost a huge. Okay, so this was exactly what ROM is and how the operating system is being loaded into the RAM. Apart from that, now let us try to understand what are the different types of ROMs available in the computer system or the computer memory. Okay, so these are the different type of ROMs that are available: PROM, EEPROM, and EEPROM. Okay, so that should be this should be classified as a separate category, but anyways, it is being classified in the same type. But nevertheless, yes, PROM, EEPROM, and EEPROM. These are the type of classification that we have for the case of ROM. Okay, now let us try to understand what exactly PROM is, what exactly EEPROM is, and what exactly EEPROM is. Okay, so PROM or the PROM is basically a read-only memory that can be modified only once by a user. Okay, that can only be modified once, only by a user. Okay, so yes, this definition is satisfactory, but see, for a long time purpose, only just mainly having this definition won't help you to remember the concept of PROM. So how can we remember the concept of PROM? Okay, so in order to remember, or in order to understand the concept of PROM, we should understand this with some sort of practical examples. Okay, how many of you have used gaming consoles like joysticks or the gamepads? If you have used, just type double Y in the chat box. You have definitely experienced that those gaming consoles have some sort of intelligence within them. Okay, okay, if somebody have used, you can understand that if you give a sharp turn or if you do perform some sort of activities, they will be giving a shocking wave, they will be giving a shock. Okay, so yes, at the same time they will be able to sense what kind of activity you are performing, right? In order to do that, there should be definitely some sort of program which is running in that gaming console, right? That program is stored inside the rom PROM chip, inside the PROM chip. This is where the use of PROM comes into role. Okay, so we are using those PROM chips inside the gaming consoles so that that program can be stored permanently. Okay, so here you can see a read-only memory that can be modified only once by a user. That means those vendors or those manufacturers whose task is to manufacture those gaming console, they will load that particular program inside the gaming console and they will be saying अपना काम बनता, बस काम खत्म, अभी जो है users इसे use करेंगे, that's it. Okay, so users will be using those gaming consoles and there is nothing changes that will be required for those gaming consoles. So permanently that program has been loaded in the gaming console. Okay, so this is one example, okay, of PROM. Okay, but if we talk about the development, then development was done by Wen Tenzing Chao in 1956, and it can be reprogrammed only once. As I said, this is the characteristics of PROM. But if you try to understand EEPROM, a programmable ROM that can be erased and reused, a programmable ROM that can be erased and reused. It is developed by Dov Froman in the year 1971, and it can be reprogrammed using UV rays or UV lights. Okay, so please try to understand these are the differences between PROM and ROM, EEPROM, PROM and EEPROM. Like PROM can be erased or can be programmed once, cannot be erased, can be programmed once. Okay, and if you talk about EEPROM can be erased but using UV lights. It can be erased but using UV lights. So the best example so that we can remember EEPROM is the smart cards that you have. So those are from defense background. They can understand what exactly smart cards are. How many of you have seen what exactly smart cards are, or those who have seen the driving licenses? Okay, there is one student. Okay, I can see 2 students have seen. Okay, there are many students. Okay, great. Okay, wonderful. Okay, so in case if you don't know what exactly smart cards are, let me show you. So this is what exactly smart cards are. Now the driving license, we have driving licenses in this format, right? We have this chip given over here, and the moment you insert this into the machine, swapping machine, you will definitely get the information of this particular card, right? Okay, so yes, there is definitely a PROM that is being installed in those EEPROM that is being installed in those smart cards, and those data can be wiped using UV rays. Okay, so yes, this is one of the most classic and one of the most best examples of EEPROMs, so that you can remember. Okay, now nowadays if you take an example of registration certificates of vehicles or driving licenses, all those cards, they have the technology of EEPROM. Okay, so that their data can be erased using UV rays. Okay, so this was the best example of EEPROM. Now let us come into the concept of EEPROM. Okay, so EEPROM basically stands for electrically erasable programmable read-only memory. Okay, instead of using the UV rays, what they will do, they will impose some sort of electrical charges, and they will use those electrical charges to erase the data of the ROM, to erase the data of the ROM. Okay, so they can be modified by the user itself. Okay, so if you want, you can modify the data, and this was being developed by George uh, Perligos in the year 1978. Okay, yes, as I said, they can be erased with the help of electrical voltages. So the example of, or the best example of EEPROM is the modern smartphones that you have. The modern smartphones that you have. You see, you have an internal storage in a smartphone, okay, which is also called as the ROM, which can be of 16 gigabyte, 32 gigabyte, 64, 128, 256, 512, or n number of gigabytes. Okay, so yes, but as of now, the maximum capability that I've seen practically is 512 gigabytes. Okay, yes, so 1 TB smartphones are also available as of today. But yes, this many slots or this many sizes of smartphones are available. Like those are basically the ROM. Because why we classify those to be as ROM? Because the entire operating system of the smartphone is being stored in that particular chip. Okay, the entire operating system of the smartphone is being stored in that particular chip, and if you want to upgrade it yourself, or if you want to erase that, and if you want to load some sort of different operating system, that can be done electrically. That's it. You just plug it into your computer, or just load a custom recovery software, and you will be able to erase that entire data and load the operating system as per your choice. Is there anyone who have ever tried uploading a custom operating system in your smartphone, or custom OS in the existing smartphone that you have? Okay, here we have Arman Das has tried. Okay, Arman Das, can you tell me which operating system that you were trying to load? Arman Das, are you there?
Yes, sir.
Okay, okay. Can you share something like which operating
So,
system you?
I was trying to install the Linux software.
Okay, you are trying to install the Linux OS in the Android device.
Yes, sir.
Okay, 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 okay. Good. So, have you installed any custom recovery for your smartphone?
Sir, actually, I was not able to do it completely. I
Okay, 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 okay. Not an issue. Definitely, within upcoming days, the moment you have a better idea of the hardware components, you will be definitely understanding how to load those operating system in your smartphones. Yes, but if somebody is doing it experimentally, please be very careful while doing that, because there might be certain times where you can even lose your smartphone, because you will be damaging your it might happen that by loading a wrong operating system, it might happen that you might damage your ROM chip, or you might damage your motherboard itself. Okay, or you might damage the firmware itself. Okay, so in that case it will be, or the bootloader, you might corrupt the bootloader. In that case, your entire smartphone will go into a boot loop. Okay, so it won't be able to load that particular operating system, but there are possible chances to recover it. But yes, if you don't do, you don't gain. So do we have to root our phones for this? Yes, there are certain devices where in order to unlock the bootloader, you might have to root your phones. Okay, you, what exactly root is, let us try to understand. Those who are new, or those who are hearing all those things like loading an operating system into your existing Android phone. Okay, so in order to do that, you will require permission. Please try to understand that. Okay, let's say if I need to go to Rishi's house, that too at, let's say, 10 p.m., definitely I will require Rishi's permission, right? Don't let us not take the example of 10 p.m., let us take the example of, let's say, 10 a.m. in the morning. For that also I will require Rishi's permission. Rishi, can I come to your place? That depends upon Rishi. Rishi will allow me to enter or not. Okay. Similarly, in order to do some sort of
Yes, sir.
modifications or in order to do some sort of changes, what you need to do is you need to gain permission of the existing operating system. That is basically the root permission. Okay. So what exactly roots are? See, Android is once again a Linux operating system. So if I show you, uh, see, don't just go with this, you will be confused. So you see a slash, so this is basically the root folder. Inside this root folder you have many subfolders, okay, where the entire files of Linux are being stored. So you need to gain access to this root folder, so you can have each and every access of this folders. Are you able to understand? तुम्हें क्या तुम्हारे पास परमिशन रहना रहेगा in order to access this folder. So that permission is basically the root. Okay, so that is basically the root. So in order to gain the permission of the root folder, so you can have the access of the subfolders inside the root folders. You need to provide, you need to perform some sort of activities by which you will be gaining that permission. So that is what exactly root is. Okay, so here you will be gaining access to that root folder, and the moment you gain access to that root folder, now you have the capability to do any modification that you want. So this is what exactly root is. Okay, so how many of you have got the idea of like what exactly root folders are in Linux operating systems? And whenever I'm saying that you can do some sort of modification in your existing smartphone, and you can upgrade the operating system as per your choice, but I'm not recommending you to do. Please try to understand. I'm not saying just play around with your smartphone and corrupt your device, because if I say something like that, definitely that might happen. It might happen that some of the students might get encouraged and they might perform some sort of activities, and by the end of the day I have the parents coming and saying that sir, you have said something and my son has damaged his smartphone, so you will be responsible for that. So that is not going to happen, students. I'm saying time and again, uh, please, if you are doing, please do it in your own risk, and please don't do in your primary device. If you have a secondary device, just then that is just kept for knowledge purpose. You can perform those sort of experiments, because that will definitely will help you to understand the concept of what exactly ROMs are. Okay, so in case the concept of ROMs are clear, what I would request is please type double Y in the chat box if the entire concept of ROM is clear. Let's move ahead to the next portion. So this was all about ROM, or the primary memory that we have, that is RAM and ROM. For RAM we have two different classifications, static RAM and dynamic RAM. For ROM we have this many classifications like PROM, EEPROM and EEPROM. Now let us move ahead to this secondary memory, or the secondary storage device. Yes, as I said, like in the last class, secondary memory is not 100% required. It's not required to run a computer system. Okay, so you can directly run the computer system even using the, even without the secondary storage device, even without the secondary storage device. But yes, if you say that computer won't be 100% usable, just merely turning on the computer and just merely accessing the BIOS interface won't help you to perform any kind of activity. Okay, so in order to use, or in order to utilize each and every component of an operating system, you need to have a software. That software is basically known as the operating system. Okay, we need to have this operating system, and yes, this software needs to be installed inside some sort of secondary memory in order to come from that memory to the uh, primary memory, right? So that operating system needs to be installed, so that that operating system can come from the secondary memory to the primary memory, specifically the RAM. Okay, so yes, this many type of devices are available. Hard disk drives, which I've already shown in my previous classes what exactly hard disk drives are, so you can have a look in case if you need to see like what exactly HDDs are. So these are HDDs. You can see this is completely built out of mechanical components. Okay, so this is what exactly hard disk drives are. Okay, so this is an enlarged view. So literally this hard disk is of I think 18 TB. Okay, so this is of 18 TB, so that's why it is so large. Okay, but if you say, then the hard disks that are being installed in your laptops are of this many size, or of the dimension of the hard disk is this much. Okay. And if we talk about the next device that we have is SSDs. Okay. So SSDs, the inner look of SSDs are something like this. So this is what an SSD looks like. Okay. But if you see the outer look of an SSD, then the SSD will look like something will look something like this. Okay. So this is the outer look of an SSD. Okay. Very clean, neat. Okay. So this is what SSD looks like. Okay. And if you want to see compact disc, I hope you have already seen CDs. So what exactly CDs look like? So these are CDs. Okay. These are optical devices. Okay. And if you talk about floppy disk, this is what exactly floppy disk looks like. This is what exactly floppy disk looks like. Okay. So the maximum size of a floppy disk when the floppy disk was very popular was up to 50 MB, 100 MB, something like that, not more than that. Okay, because in that time MB was a huge size. As of now GB is a huge size, but yes, a time will come when we will definitely surpass GB. Okay, now after the floppy disk, that the next storage device that we have is magnetic tape. Tapes. So this is what exactly magnetic tapes are. Can anybody tell me how many of you have seen this magnetic tapes or have used this sort of magnetic tapes? Let's see. Okay, just say yes. Just raise your hands. Okay, two students have used this magnetic tapes. Okay, three. Please don't feel shy. In case if you have used, please raise your hands. Let's see how many have used this magnetic tapes. Because I believe uh, these tapes are obsolete as of now. So in case if you have used, that means it is a big thing that you have at least seen these tapes. So these are magnetic tapes. Okay. Yes. So this was all about the secondary storage device that we have for computation, like the hard disk drive, secondary storage devices, compact disk, floppy disk, and the magnetic tapes. Let's move on to the next portion of the concept, the topic, that is input devices and the output devices. So what exactly input devices are? We know as of now. Okay, input devices whose responsibility is to capture the input. The responsibility is to capture the input that we provide to the system. Okay, but yes, the input that we provide to the system can be in the form of electromagnetic waves. Okay, and that electromagnetic waves needs to be transmitted or needs to be converted to digital signals, because we know, yes, computers, they only understand digital signals. Okay, let us try to decode the meaning of digital. Okay, so whenever we talk about digital, that term digital has been derived from the word binary digit. So we know that in binary digit we have 101010. So binary digit, right? Binary digit. From here the term digital came. Okay, binary digit का digit से जो है digital वाला portion हमें देखने को मिलता है, या फिर बाइनरी डिजिट का जो डिजिट वाला पोर्शन यहाँ से जो है डिजिटल का इंसेप्शन हुआ है. Okay, so this is what exactly digital means. That means we are definitely going to deal with binary digits. Okay, so yes, whenever we supply input to the input devices, then those inputs they generally come in the form of electromagnetic waves or analog signals, what we call. Okay, and those analog signals needs to be transmitted or needs to be converted to digital signals, and those conversions are being done by the input devices that we have. Okay, see, the moment you press a key, you're pressing a key, and the entire thing, that activity that you're performing, like pressing a key, is completely non-digital, right? Like pressing that and converting it, getting that sense, getting that pressure and converting it to the digital signal is a separate task, and that task is being performed by the input devices. So if you talk about input devices, we have devices like scanners, mouse, keyboard. Even the modern touch screens are also to be classified as the input devices, because they have both the capability of supplying input as well as giving you the output. So if you talk about touchscreens can be classified as output devices as well as input devices, because through that screen you are able to see, as well as through that screen you are able to supply the input to the system. Okay. Yes. Even nowadays, the smart speakers that you have, like the Alexa or the Google Assistant or the Siri or Bixby, so all those have the capability to sense your voice. Once again, those analog signals are being captured, like your voice is being captured and is being converted or is being transmitted to the system in the form of digital signals. Then only it is able to process it. Okay, and the task of output devices is to convert those digital signals and convert it to the analog signals so that you can understand the output. So what if the entire processing happens and the monitor displays the data in the format of zeros and one? In that case, that will be of no use. Okay, that computer, even if the computer is very powerful, that computer won't be of any use, because each and every time it shows the output in analog signals and nobody will be able to understand that. For that, we will need a separate converter which will convert that again, will convert that output and will display that particular output. Okay, but yes, in order to understand the output that in order to understand the data that is being processed by the computer, so that we can gain some sort of meaningful informations, we will definitely require some sort of output devices. Okay, so this is some sort of output device that we have, like the display monitor, speaker, printer, and 3D printer. If you need to print structures, in case if you have not seen what exactly 3D printers looks like, then just have a look. So here we have the filament. You can see there is a wire which goes here. Okay, and that wire comes to this nozzle. There is a nozzle over here. Okay, and the program is being loaded. As per the program, it will print out the structure. Okay, let's say if you want this. How many have seen Star Wars? If you have seen Star Wars, then you know what character is it. Okay, so if you want to print this character, so that can be printed using this printer. There's a filament or there's a wire which goes over here. This filament will be melted by this device, and you will get the structure printed over here. Okay, so this is what exactly 3D printers look like. So this is what exactly 3D printer is: printers and speakers and the monitors. Okay, so I hope the concept of input devices, output devices, like what are the working principle, like how they work, and what is the basic task, just not to provide the output. They have also the responsibility to convert that particular process data from analog to digital, digital to analog, vice versa, so that the computers or the users can understand what output or what input is being supplied to the system or the user. Okay, so if you talk about if you talk how the touch screen works or how the monitors work, in case if you're interested, please let me know in the next class, or whenever you feel like I will be able to explain those input devices or the output devices. So this was all about today's class. In case if you have any kind of query, you can ask.
Get